Let us do problems on dependent sources. For Thevenin's and Norton's theorem, procedure is same. If there is a dependent source, so find current through 16 ohm using Thevenin's theorem or Norton's theorem, whatever. Okay, Thevenin's theorem or Norton's procedure is same. Okay, determine current through 16 ohm using you write Thevenin's or Norton's theorem. Okay, now first check is there any dependent source is there. You can see this is a independent source, plus minus it is an independent source. There is a diamond shape. If there is a diamond shape, it is a problem on dependent source. So there is a dependent source. So what is arrow mark is there? Arrow mark means it is a current source and its value depends on Ix. It is zero point 0.8 times Ix, where Ix is such entire circuit where Ix is this. It is 16 ohm. So they ask to determine current through 16 ohm. It is a load actually. Find current through 16 ohm. No, this is your load. Okay, load resistance is 16 ohm, and actually whatever current is flowing in the load, it acts as a control for this current source. It is a current controlled current source. Zero point 0.8 times this Ix value. If there is a value of Ix, then it acts. If there is no value, this will be zero. So here first step is we identify this is a load and there is a dependent current source with value zero point 0.8 Ix, okay, where Ix is current in the load. So in the problems related to this dependent sources, finding RTH is different actually. Finding RTH is given as open circuit voltage. We identify this is a load. We have to find out open circuit voltage across this. That is nothing but your VTH. And you have to find short circuit. You have to remove RL and you have to short circuit and you have to find short circuit current here. And after that, RTH is given by VOC, open circuit voltage by short circuit current. For all the dependent source problem, the only way to find RTH is, okay, you have to find open circuit voltage and short circuit current, and RTH is given by VOC by ISC. ISC means short circuit, VOC means open circuit voltage. So now let us find out. We removed the RL. We removed the RL here, and we have to find open circuit voltage. That is nothing but VTH here. Okay, open circuit voltage. Now, once I open this, current in this second mesh becomes zero. Okay, current in this becomes zero, and here Ix becomes zero. Actually, Ix was here. Okay, actually, Ix was there. Here, Ix was there. Now, Ix is this RL is removed, so Ix becomes zero. This portion, Ix current is equal to zero, so Ix is equal to zero. When Ix is equal to 0, what happens to the dependent source? Zero point 0.8 am. So current source also becomes 0. 0.8 into 0. It is also becomes 0. When zero point 0.8 into Ix is equal to 0, current source is equal to 0 means open circuit. This also becomes open. This also becomes open. This also because you remove it. Current source 0 means open. Don't short it. Current source. Now I have to find VTH across this. It is there is no current also flowing in this equivalent circuit also no because it is open. And no current is flowing in 10 ohm, no current is flowing in 6 amps also. No currents are flowing in this branch. So if I keep multimeter positive here, negative here, this point A is at this point B at this point. So VTH is directly, it is same as 40 volts only. So VTH is 40 volts. So first part is over. Next we have to find out short circuit current IN. Short circuit current IN. So where I removed the RL, first we calculated open circuit here. Open circuit here. Now we have to short it and short circuit current here. Now this is Ix only. Ix is same as your short circuit current IN. Now this current source is not equal to 0 because there is a closed path. Please see here there is a closed path and some current will flow through this and that there will be a value of zero point 0.8 times this value. Okay, you have to consider this also. Now you can apply mesh analysis or nodal analysis or any suitable method you can apply and you can find what is the current in mesh 2. Okay, now here this IN is same as IX, I2 is also same as IX and IN because IX, IN, I2 all are belongs to mesh 2. all currents are same. Ix is also equal to I2. Now, if I solve this using mesh analysis, I cannot apply KVL for mesh 1 because I don't know resistance of this. I cannot apply KVL for this because I don't know resistance. So solution is, this is a problem on super mesh. So we have to combine these two mesh and form a super mesh. You have to combine mesh 1 and mesh 2 and form a super mesh, and I can directly write one equation. It's a current source. It is going down. I1 is also going down. I2 is going up. So I1 minus I2, because current is going down, it is mapping with I1. So I1 minus I2 is 0.8 times Ix. I1 minus I2 is 0.8 Ix. I don't want any other variables. All the equations should contain only mesh currents I1 and I2. So you have to replace this Ix with mesh currents. So we know that Ix is same as I2. So replace Ix with I2. So I1 minus I2 is 0.5 times I2. This 0.582 you bring left side. So minus 1 minus 0.8, total is minus 1.8. So I1 minus 1.8, 8 is equal to 0. That's equation number 1 or 2. And one to solve two mesh equations, two unknown variables, at least we get two equations. One equation we got, another equation I cannot apply KVL for mesh 1, I cannot apply KVL for mesh 2. We form a super mesh, this outer path. For this outer path, you have to apply KVL. So if I apply KVL, you can write this is you can write a KVL. I told no. Either you can consider minus to plus. Okay, you can write minus 40. Then always current flows from plus to minus here. This is plus. This is minus. Plus minus plus minus, because I2 is also flowing. Always current flows from plus to minus. Okay. So while writing KVL, you can consider minus 40 plus 10 I1 plus 6 I2 is equal to 0, and you bring all the things to right side, you will get minus 10. Minus plus 40 minus 10 6 I1, or another equation will be minus 40 plus 10 I1 plus 6 I2. So you can, because in some textbook they will consider minus to plus as positive, that is rise in voltage, and this is a drop in resistance, they consider as minus. In some textbooks they will write plus whatever you will get now first year. Here what is there? Minus. First you got minus to plus. No, minus will write. Next it is plus to minus. So we will write, consider plus. This is also plus to minus. So we will consider plus. So you can consider beginning one. Simply is here minus plus plus you can write. Otherwise at the end, this is minus to plus. No, this side we have plus. You can write plus. Here plus to minus. This is minus and minus. You can write plus minus minus, or consider beginning what you got minus plus plus. Both are correct. We will get this equation. So that is equal to 10I1, 6I2 is equal to 40. You write whatever method you know, you will get same equation only. Okay. Now we got two equations. These two equations are in matrix mode, and you can solve using equation number 2 and 3. You can solve using calculator. So go to calculator, go to mode, equation mode. Now select equation mode 5. So there are two unknown variables. Which are the two unknown variables? I1 and I2. So select two variables, first option. Okay. Yeah, this is 1. Coefficient of I1 is 1, is equal to minus 1.8. Minus 1.8 is equal to right side value 0. Already 0 is there. Sorry. 0 once again you have to enter. 0 is equal to, next to 10 I1. You have to carefully enter coefficient of I1 only in the beginning. And 6 is equal to 40 is equal. So if you solve this, we are going to get this is equal to x is equal to 3. X means I1 equation current is 3 amps and I2 is 5 by 3. And from the figure we want short circuit current IN. So IN is same as I2. So I2 is 5 by 3, or you can also write 1.6667. Okay, it is 5 by 3 or 1.66667. That is short circuit current IN. Now to find the RTH, what is the formula? In the case of dependent source only, whether it is the Norton's theorem or Thevenin's theorem, you have to find RTH as open circuit voltage by short circuit current. Open circuit voltage we got 40 volts, short circuit current we got 1.667. So this will give you 24 ohms. So write Thevenin's equivalent circuit as 40 volts in series with 24 ohms series. If it is a Thevenin's theorem, you have to write 40 volts in series with 24 ohm. If the same problem asked using Norton's theorem, you have to write IN value. Okay, 1.66 amps in parallel with 24 amps. So 1.6, or you can convert this one to current source, that will give you Norton's. Convert this one to current source, it will give you Norton's. That current value is 1.667 upwards, and same 24 ohms you have to connect parallel. And after that, using Thevenin's theorem, find the current through this RL. So it is a simple circuit, one voltage source with two series resistance. So voltage 40 divided by 24 ohms and 16 ohms. 24 ohm and 16 ohm. 40 divided by 40 is 1 amp. If the same problem is asked to find using Norton's theorem, then you have to write short circuit current parallel with 24 ohms. Then branch current is equal to main current, resistance opposite to 16 ohm is 24 ohm, divided by this. That will give you same answer of 1 amp. And if the same problem is asked to find maximum power delivered to this load, so if they will give RL here, they will give RL. What is the value of RL for maximum power means? Same procedure only for all the problems, same procedure. For maximum power transfer to the load, RL should be equal to RTH. RTH is how much? RTH is 24 ohm. Here actually 16 ohm is there. For maximum power transfer, this should be 24 ohms. And the maximum power value is VTH square by 4 times RTH. That is why I explained this one here only means, because in the maximum power transfer theorem, the aim is you have to obtain Thevenin's equivalent circuit, and for maximum power, RL should be equal to RTH. So instead of solving one more time, the same problem is asked for maximum power transfer theorem also. For maximum power transfer theorem, R value should be equal to 24, and maximum power value is VTH square by 4 RTH. So for this problem, just remember, for any problem related with dependent source problem, you have to identify the load, and you have to find open circuit voltage across it using any technique, find short circuit uh, current across it using any technique, and RTH is found out by open circuit voltage by short circuit current. Replace with, if it is a Thevenin theorem, replace with the Thevenin circuit. If it is a Norton's theorem, replace IN with parallel with RN, connect RL once again, and using current division, you have to calculate current in the Norton's theorem. Using simple this equation, you can find current in the Thevenin's equivalent circuit. So in this problem only, you will understand same problem can be solved using Thevenin's theorem. Same problem can be solved using Norton's theorem. So instead of 16, they will give just R, and they will ask you to find what is the value of R for maximum power. So for all these problems, same solution, finding RTH and VTH, open circuit voltage, short circuit current, RTH, and easily you can solve the problem.